Okay, this is your video for this today. So let's start. Polynomial functions of higher degree. We've been working with quadratics. We're moving into the next section, and we're going to talk about degrees that are higher. Degree meaning the exponent is higher than 2. So in this section, you will use transformations to sketch graphs of polynomial functions. Use the leading coefficient test to determine the end behaviors of a graph of polynomial functions. And finding the zeros of polynomial functions as sketching aids, or in other words, using them to help you graph them. Let's get some words out of the way. Nomenclature is just like what do you call stuff, names of stuff. These 2 points on the graph of any polynomial, the parts where they cross the x-axis, there are a bunch of names for the same thing, and they are kind of confusing. You're probably going to wonder, what are they asking for? Well, sometimes we call them zeros. This is a 0, and that's a 0. That's because the y value is 0. So this is 2, 0, 6, 0. That's why we call these zeros, these 2 points on the graph. Okay. Sometimes we call them roots because these are the places where this parabola has roots, or that's where they can begin. That'll make a little more sense in a minute. Or solutions as 2 and 6. Factors, x minus 2 and x minus 6 are also referring to these 2 points on the graph. And x-intercepts. X-intercepts would be 2, 0 and 6, 0. Those are x-intercepts. So these 4 ways of calling these 2 points makes it kind of confusing. I just want you to know that they all are talking about the same thing. Okay? I want you to think about these 2 functions, and we're going to relate all of our higher degree functions to these 2 basic ones. You know what the difference between these 2 are? This is linear, this is of a line, and since we square the x, we've actually taken the line and bent it once. So this is a parabola. We bent it into a parabola. So basically we have these 2 things going on. So we're going to look at only the end behaviors. On a line, they have to face in opposite directions. Whereas on a parabola, they face in the same direction. Now what if the 2 was negative? Then it would be a negative slope, right? So right now, as we write it with a positive 2, it goes down to the left and up to the right. If the 2 is negative, then it will be up to the right and down to the left. Both of these point up because the 4 is positive. If the 4 was negative, this would be upside down parabola, then they'll be both down, so they'll be down to the left and down to the right. Since the 4 is positive, we say it's up to the left and up to the right. This points both are pointing up because the 2 here, and this points in opposite directions because of the 1. The 1 is odd, okay, and that's what makes these 2 happen like that. And the 2 is even, that's what makes that happen like that. Okay, so let's move into the higher order, things higher than 2, like this. That's a 5, okay? Higher order, I'm covered up this. This is odd. When it's odd, they're either going to point in opposite directions where the right goes up and the left goes down, or if this is negative, it's going to be up to the left and down to the right. You notice that this is a negative 6. It's going to be up to the left and down to the right because it's negative. If this was a positive 6, it would be down to the left, up to the right, just like on a line, right? A line with a positive slope. This is a line with a negative slope. We don't care what happens in between at the moment. It could look like anything in the middle. We don't know what that is, but we're just looking at the endpoints. Okay, that's real important. For odd exponents, the endpoints are going to go down to the left, up to the right, if the leading coefficient, that A value, is positive. If it is negative, it's going to go up to the left and down to the right. All right? What happens when it's even? Well, when it's even, it looks like a parabola. When it's even, both ends are either going up when the 6 is positive, or both ends are going down if the 6 is negative. So if we look at it, we don't know what the middle part is, so we actually don't care at the moment. We're only looking at the ends. Okay? We're only looking at the ends. Just remember, the leading coefficient test is looking at the ends. Up to the left, up to the right, down to the left, down to the right. That's because the exponent is even. So let's see if you really understood that. Use the leading coefficient test to describe the left and right hand behaviors of the graph. So this is odd, odd, odd. Let's see, odd is odd like a line or parabola. I think it's like a line with a negative slope, right? The exponent is odd, so endpoints act like a line. Since A is negative, like a negative slope, so that means it rises to the left and falls to the right. Let's do another one. The exponent's even, so the endpoints act like a parabola. And since it's a positive one in the front, it's a parabola that opens up. So that means it rises to the left and rises to the right. What about this one right here? That's odd. So it's odd, so it acts like a line. And the endpoints of a line are going to go down to the left with a positive slope and up to the right. I think you may not be able to see that. Just realize that may be off my projection area. All right. Next. What about this one? What are we looking at here? We're always looking at the largest one right here. Okay? We are going to be looking at this part right there. We're going to ignore this. Okay? In this one, we're going to just look at this right here. We're going to ignore all that. Okay, so let's see. For this, since the exponent is even, it's going to act like a parabola. Since it's negative x to the fourth, it's going to open down, so it falls to the left and it falls to the right. What about this one? This is a negative 1/4 x cubed. So now this is going to be like a line because the 3 is odd. And the negative 1/4 means that it has a negative slope. So a negative slope is going to rise to the left and fall to the right. Okay. What about this one? Well, if I distribute this, I'm going to get an odd leading coefficient. I don't look at any of this stuff here. Okay, so that's going to look like a line, and since it's a negative 2, it's a negative, so it's going to look like a line with a negative slope. So it rises to the left and falls to the right. How's that? All right, let's go on. Okay, we're going to find the zeros. So what that means is, I think I talked about this before in another lesson, you're going to make this 0. Okay? And for all those awesome people out there, you know that to find the 0, you're going to use the zero product property. So if we use the zero product property, we need products of factors. So we're going to factor this. Anybody know how to factor that? Pull out the greatest common factor always, first step. Okay, and then you can do a guess and check here. there's not too many numbers, factors for negative 2. I believe negative 1 well, one of them has to be negative, one of them has to be positive in order to get a negative 2. 1 times 2 is the only way you can make 2. And since I want a negative in the middle, I'm going to have to make this one positive, right? Because these two will give me the x squared, and these two will give me the first terms, and the last terms will give me the negative 1. The first terms will give me x squared, and then the inner and outer ones added together will give me a negative 1. So now we have a product. There we go. We have 3 pieces that equal 0. So I know that x is equal to 0. That's the first piece. The second piece is x plus 1 is equal to 0. That means x is equal to negative 1. And then we're going to have a third piece. 0 is equal to x minus 2. Add the 2 to the other side. So x is equal to 2. So your zeros are going to be at, oops, don't want to write it that way. I want to write it as zeros are at 0, negative 1, and 2. Okay, very good. So you think you're going to get to do one. Try that one. Pause it, and then when you're done, check to see if you did it right. Okay, so after you're done, you're going to watch this and you go, oh, I'm going to factor out the greatest common factor, which is x. And I believe this is going to be x times x minus 6, and then minus 6 again. That's how I'm going to get a 12 and 36. So now I split this up into 3 pieces. Oh, these two are the same, so I'm not going to do that one twice. I'm going to just do that one once. Add the 6, so x is equal to 6. And there are actually 2 6's. And I'm going to have you write it like this for now, okay? Because there's something really important about having more than one 0 at the place, because the graph would look different if you had 1 6 or if you had 2 6's. So write both of them. Okay? All right. Let's move it on. I think there's one more. Yeah. Okay, let's see. Find all the zeros and relative extrema. So let's find the zeros first. Greatest common factor. What's the greatest common factor here? I believe that's a 2x squared. Factor 2x squared, I get a negative x squared plus what times this will give me this? I believe that's a 1. Right? If I distribute that, I should be able to end up with what I started with. That's how you factor. You multiply it out, you should end up with what you started with. Okay, now we're going to use the zero product property. First we're going to start with this side, and we're going to solve that. Divide both sides by 2. Take the square root of 0. Okay, so I get 2 zeros. Don't forget, 1 here and 1 here, right? This is x times x. So both of those are going to give me a 0. And this one is going to be negative x squared plus 1 is equal to 0. Add the x squared to the other side. Take the square root. You take the square root of a square, square root of a square, square root of a square. I want that to ring a bell in your head. Square root of a square plus or minus. Okay, so there are 4 solutions. There's a rule. It's called the fundamental theorem of algebra. This tells you how many zeros you're going to have. Up to, there could be no zeros, 1 0, 2 zeros, 3 zeros, or 4 zeros. And in this case, we found all 4 of them. Okay. Oh, that looks like a face. Ah. Okay, so your zeros are at 0, 0, negative 1, positive 1. The relative extrema. The relative extrema you're going to find with your graphing calculator. Once you put it in there, you're going to find the maximums or minimums of each part of your graph. Okay? I'm not going to do that here because that's just going to slow me down. It's going to make this video too long. But when you get into class, you can try this out. Don't freak out, please. Okay. There's a couple of ways you can handle this. You can be super awesome and just do it with all these fractions. Or you can be super smart and get rid of all these fractions. You know that when you find the zeros, you're going to put a 0 over here. And I love having 0 on one side because that means I can do a whole lot of multiplication to the problem without affecting it. So like a great mathematician that all of you are, you're going to know that, hey, I can get rid of all these fractions by multiplying the whole thing by a 4. Right? Distribute a 4. And I can do this because when I multiply this side by 4, it's still 0. Yay. So now that's 0. The 4 cancels with this 4, so I'll get a negative x to the 4th. The 4 reduces with a 2, and I get 2. 2 times 3 is 6. And then you cancel that 4, and you get negative 9x squared. And in case you don't believe me, here's 4 times 3 over 2. Put this over 1. You can cancel this, or you can multiply this as 4 times 3 is 12, divided by 2 times 1 is 6, or reduce this. Make that a 2, make this a 1, that's 6 over 1, right? All right, this is much better. Okay, I'm going to factor out a negative x squared. Okay, that's my greatest common factor. I get x squared minus 6x plus 9 because I factor out a negative. And I know this factors to x minus 3. X minus 3. And then you can solve this, right? 0 is equal to x squared. Negative x squared or x squared doesn't matter because you're going to divide both sides by negative. That's gone anyway. So now two of my zeros are going to be 0 and 0 for both of these. Because remember, this is x times x. I get a 0 for this one and a 0 for that one. And I get 2 3's, positive 3's. So there are my 4 roots for this. Just remember, you could get up to 4. You might only end up with 2 or 1 or no solutions. Or no zeros, or 3. Okay? Relative extremas, you can do that on your graphing calculator. Okay, sketching the graph. This is what I need for you to do. Okay, you're going to find the zeros. The 0 is going to be 0, right? We just did these, 0 and a positive 1. Because if I put a 0 on this side, let me write on this side. Okay, for 0, that means x is equal to 0, and x minus 1 is equal to 0. So my zeros are going to be at 0. My 0 is going to be at 0 and 1. So I'm going to put that on my graph, 0 and 1. This is what we're going to estimate. This, if I distribute this out, it's going to be x squared minus 1x. And from the right hand and left hand behavior, this behaves with the rises to the right and rises to the left. It rises to the right and it rises to the left. That means I can just put my graph through there. Now they ask you to find how far this goes down. I don't care how far this goes down, because they want you to find how far this goes down with your graphing calculator. Well, if you're going to find how far it goes down with the graphing calculator, you've got this thing done already, all right? Because that doesn't make any sense to me whatsoever. So you can draw it like that. You can draw it like this. You can draw it like this. What I'm trying to tell you is you don't know how far it's going to go down. And I don't care. Okay? The important parts are you know exactly where they cross the x-axis. Those are your zeros. And you know the end points behavior. Okay? If you put one endpoint down here and one up there, I know you did wrong, but both down here, they both have to be going up. Rises to the left, rises to the right. Let's do another one. How about this one? Okay, we have x to the third, so that means we have 3 zeros and a 1. Okay. This is going to look a lot like the other problem, and this is going to be an even, right? X to the fourth. When I distribute this, even is going to look like that again. Okay, except I know there's some squiggly things going on down here somewhere, but I don't care. All right. All I care about are the zeros, the left and right hand behavior. This is a good time to point out something. If you have an even number of numbers of zeros that are the same number, I just said number like 4 times. Okay, if you have an even number of zeros or an odd number of zeros, that's going to change the way this graph is going to look. If you have an odd number, like only 1, 1, or 1, 2, 1, 3, the line's going to go through those points. But if you have an odd number, or even number of the same number, they don't go through. They bounce off of it. Okay, so let's say let me clean this off. Let's say your graph had your zeros are -2, -2, 0, and 5. Okay, so there are 4 zeros. That means the behavior. I have to also tell you that there are 4 like this. So you know it's going to be up and up, and you know that it's going to go through the -2, 0, and 5. Okay? You know it's going to be up and up. So you know it's going to, because they're -2s, you're going to bounce off the 2, come through the 0, come back through the 5. That's how it's going to look. You're going to know you did something wrong if you do this. Let's say you did not know that you're supposed to bounce out and you went through it. So you went through there, you went through here, and then you go through the 5. Look, do you see a problem? Yeah. When you go through the 5, there's no way you can get back up here. Some people force it and they go, oh yeah, I'm going to go back up here. But look what you just said, you made another 0. You made another 0. Bad. Don't do that, okay? All right, you can't make your own 0. Okay. And when you, one more thing, when you're making your bouncing off of a number, all parabolas have to be smooth. Okay, no corners. Don't come up and go, oh, I'm going to bounce off of there like that. Okay, it can't be pointy like that. It has to be smooth, so swing around wide like you're making a turn in a car. If you drive, all right? If you don't drive yet, well, even if you don't legally drive, I'm sure some of you have tried it. So you have to swing around in order to make a turn, go wide, and come around and touch that point and go on your way, okay? don't try to hit directly at it. You can't turn then. Okay, so you want to be able to turn. So come around, swing wide, go touch that point, swing around, make that round, go through and up like that. All right. So how do you know when you bounce off? When you have an even number, bounce. And if you have an odd number, oh, sorry, this is not a good example. These are even numbers. No, even number of numbers. There are 2 negative 2s and 3 5s. Okay? Odd, you go through. Let me write one more just to clarify. If you had 3 4s, this is a through. It's yeah. Okay, if 3 4s, then this is going to go through. Okay, because this is odd number of 4s. Okay, that's why a few minutes earlier I told you have to write out the number of zeros even though they're the same number. Okay, one more. Here's a nice one. See if you can do this. This is awesome if you can do it. If you can do it, I'd be impressed. If you want to pause it here and try it. I'm going to do it now, so I hope you've tried it. You got 3 zeros. Got 4 1s. Right? This is do it 4 times. I go to -3 and a -5. All right, awesome. And then if I multiply all this out, this multiply this will give me x to the 4th. X to the 4th times x is x to the 5th. Multiply that will be x to the 6th. So my left and right hand behavior is going to look even, so they're both going to go up. So it's going to go up and up on both ends. You see how I got that? There's 3 x's here times another x, times another x, times another x. Okay, if you FOILed all this stuff out. Ooh, wait a minute. I misspoke. Back up, back up, back up. Okay, I misspoke. There are 3 here, and there are 4 here. That's 7, 8, 9. So 9 altogether. It's going to be an odd. Sorry, odd. Okay, see what I mean when I told you I'd be impressed if you could do it? I almost messed this up myself. Okay, so they're odd, so it's going to go down to the left and up to the right. So now I have 3 zeros. I know I'll be going through that point. 4 1s. I have to bounce off the 4. 1 -3 goes through the -3 and goes through the -5. So I know I'm going down on the left, up on the right, because it's odd and it's a positive odd, right? Okay, so it's going to go through the 5. I don't care how far up you take this. Come back down through the 3. Come over here to the 0. Go through the 0. Bounce. Take it nice and wide. I know you don't have much room. Take it nice and wide. Bounce off the 1. And finish. That is beautiful, even though it doesn't look like it. Okay, the result is beautiful. Down to the left, up to the right, through the -5 because there's only one of them, through the -3, through the 0 because there's odd number 3 zeros, and then bounces off the 1 because there are 4 1s, and it goes up to the right. Here's another one. Let's see if you can get through this one. Okay, I'd be impressed too if you can do this one. Not quite as impressed if you did it perfectly on the last one, but still impressed. All right, so I have 1 0. I have 3 positive 4s. and I have 1 positive 3 and 2 negative 1s. Okay, you can count them up this way, or you can just count up this way. But sometimes if you've made a mistake down here, then you're going to double your mistake by counting these. So if you want to count these, 1 plus 3 is 4, plus 1 is 5, plus 1 is 6. Let's see, 1, 2, 3, 4, 5. 1 plus 3 is 4, 5, oh, 6, 7. Sorry, there's 2 here. Yikes. See? Okay, there's 7. 1, 2, 3, 4, 5, 6, 7. Okay, so I have a 0, 4. I'll be going through the 4, be going through the 3, and I'll be bouncing off the negative 1. And because I have 7, and this is still positive, right? When we multiply all this out, it's still positive in the front. Multiplied it all out, not just because it's 3. So now I'm going to go down, positive, and it's 7, so it's going to be down and up. So I'm going to go through. Nope. Whoop. Negative 1 is, there's 2 of them. I can't go through it. I have to go nice wide, swoop around, go through the 0, go down, go up. Okay? No pointy things anywhere. Okay? It has to be smooth everywhere. And if I was doing this on paper, I think I could make it look a lot prettier than this. And just using this tablet, it's kind of hard. Okay, let's see how long this video is. I hope it wasn't too long. Apologize if it was. All right, remember to fill in your Google form. See you tomorrow.